Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new problem which says the probability of getting a sum of 6 when a pair of dice is thrown. Okay, so this question is very interesting. First, try to understand total number of sample space. So, number of elements in sample space. So you know that if I'll throw a dice once, the total number of outcome would be 6. 1, 2, 3, 4, 5, 6. And we have thrown pair of dice. So the number of dices will be put on the power. So it is 6 power 2, it is 36. So total number of elements in sample space would be 36. Now we want the probability of getting 6. We want 6. Okay, so look at this, favorable outcomes. Favorable outcomes. So in favorable outcome, if you'll observe, we can expect 1 comma 5 sum up to 6, 2 comma 4 sum up to 6, 3 comma 3 sum up to 6, 4 comma 2 sum up to 6, and 5 comma 1 sum up to 6. So these are the favorable outcomes. Now we have to find out the required probability. The required probability is number of favorable outcomes. So what is the number of favorable outcome? 1, 2, 3, 4 and 5. So total number of favorable outcome is 5 and total number of possible outcome. Total number of possible outcome is 36. Hence the required probability is 5 by 36. Okay, now let's jump on to the next illustrations. So we have a pair of dice is thrown. You have thrown a pair of dice. Now try to understand this part. If you will throw a pair of dice, total number of possible outcomes, it would be what? If I'll throw a dice once, I'll get uh, total 6 possible outcome. Okay, 1, 2, 3, 4, 5 and 6. Now you know that I have thrown pair of dice, means we should put it on the power. So the total number of possible outcome is 36. Okay, then we have this. Find the probability of getting some 10 or more. Okay, so we have to jump on to the favorable outcomes. Favorable outcomes. Now focus on favorable outcome. I want sum to be 10 if 5 appears in the first dice. So the condition is this, that you should have 5 on the first die. Okay, so 5, suppose I want 10. So for that 5 and 5. There is no other combination of making 10. Okay, then suppose that I want 11. So you know that first 5 is fixed, second would be 6. So 5 and 6 is 11. Suppose I want 12. So you know that if you will put 5 in the first dice, you cannot put 7 on the next dice, because you know that the maximum value a dice can accommodate is 6. So these are the two favorable outcomes you can expect. Okay, now can I say that required probability is number of favorable outcomes? So the number of favorable outcome is what? 2 upon total number of possible outcome is 36. Therefore the required probability is 2 by 36. I hope The idea is clear and you guys can handle similar situations. So see you guys in next session of MathFlix.